So, hello everyone. Today we are going to talk about gradient descent. I'm going to write first gradient descent. So, what gradient descent is used for? It is seen as an optimization technique, right? It is used for optimization. So, what it is optimizing? First we have to see this, right? So, if I take an example of linear regression. So in linear regression, what we were doing is that we used to find the minimum squared error. We used to find the minimum squared error, and then we used to determine the best fit line. Best fit line. And like how do we reach the conclusion that a particular line is a best fit line? So like if I if I if I take a graph and suppose I'm plotting 5 points. So suppose let's say this line is our best fit line. Best fit line. So how a machine is able to find this best fit line? So like what we are doing here is that, so we know that our line formula is y is equal to mx plus c, right? So what gradient descent does it is that it is used to find like two values for every position, that is m and c. And if I talk about in terms of machine learning language, so m is known as weights and c is also called bias. So these are the two terms that we used in machine learning, okay? And if I talk about like how does it optimize, right? So we used to like we have two, that is x, okay, and y. We have these two values. So what we are doing is that we are calculating m and c for every value of x and y. So m, if I talk about m, okay, m is the slope. So if I talk about m, this slope, or we can say the steepness, right? So this thing is called m. And if I talk about c, right, c is just an intercept. So let's suppose this line is passing through here, okay? And if I talk about c, this value is the c, right, the height of this thing. So this value is c, okay? And what gradient descent does is that it is used to find for every value of x and y, that is it finds the value of m and c, okay? So if I talk about another thing, right, if I talk about the learning rate. So what learning rate what happens through learning rate is that it iterates, right? Machine iterates the value. Iteration means that let's suppose we did not find the optimal value, right? So what it does is that it again iterates the value, it again changes the value of m and c and checks that if the value is optimal, right? So what happens after iteration is that it is used to find optimal value. Optimal value. And if I talk about the learning rate, I will write it here. So what happens in learning rate is that it is the steps that are taken. Think about it as the steps that is required to reach that optimal value. So this is what the learning rate is. And if I talk about the steps taken, right? So I will show you with now with a graph that there are like different types of learning rate. I will write it here. Different types of learning rate. So let's suppose we are taking a baby steps, right? Very small steps. And if I with the graph, let me show. So suppose this is the error rate, right? Y-axis is showing the error rate, okay? And if I make a graph here, let's suppose this, think of it like think of this graph like a valley, right? Think of this as a valley, okay? And for let's suppose my first iteration, the value came out here at this point. At this point, my value came, okay? And if I have to, like, let me zoom in. And if a machine has to lower its error, right? So to here, I have to reach from here to this point, bottom of the valley, right? So if I draw a line here, a dashed line, so this point is called minima. This point is called minima. That is the lowest error, like error rate we can get, okay? And if I talk about the small steps, right? So suppose, like, machine iterates, okay? It iterates again, it reaches this point, then it iterates again and reaches this point, like you can see, okay? It is iterating, it is taking small steps, and it is reaching, okay? You can see these small steps. Through these small steps it is reaching, its error is coming down, okay? Think of it like this. And if I reach here, okay, so I have reached here, this is my minimum error rate, okay? Or we call it global minima, okay? global Global minima, okay? So this, as we can see that, like, if we take small steps, okay, so what we are doing is, what you can see from the notice from the graph is that we are taking a lot of iterations, okay? So we are taking a lot of iterations. And what happens is that the problem with it is that we are like, it will take a lot of time. It will take a whole lot of time to reach the minimum possible error that I can get, okay? So this is what is like, what is the problem with small steps, okay? And if I talk about another type of iteration, right? So suppose, like, we are doing the opposite of small steps, we are taking very large steps, okay? We are taking large steps, then what will happen is that, if I, okay, so this point is our, again, a global minima, okay? A global minima. And, like, I'm here, I am at this point, okay? So I have to like, I have to reduce my error rate, okay? So if I take very large steps, I'm here, then I'm here. Okay, then the problem with the last step is that if I take too much of a large step, then the opposite thing will happen. Okay, as you can see, I reached here from this point I reached this point. Okay, I'm encircling it. From this point I reached this point, and from this I reached here. Okay, what what if I missed this point? Okay, what what will happen if I miss this global minima point? Okay, I'm reaching here, then here. So like you can see that I'm overshooting the valley. Okay, I am overshooting I'm overshooting the valley, means that I'm missing my global minima point. Okay, and then opposite thing is happening is that here you can see here is that error rate is increasing again. Okay, our error rate, which was meant to be decreased, it is increasing again. The opposite thing is happening. Okay, if we take very last step, our number of steps may be reduced. Okay, but what is happening is that we are like missing our minima, that minima point. Okay, that optimal point. Okay, and what we are doing is that opposite thing is happening is that we are going like up the valley. Okay, so if we talk about it, so let me give you another example. Let's suppose we have mountain here. Okay, and we are here. Let's suppose we are here at this point. Okay, so our aim is to move down. Okay, move down here till this flat portion. Okay, then like let's suppose the height, let's suppose this is the error. Okay, this was my error. Then I'm moving down the valley. What it means that we are reducing our error. Okay, and I talked about in case of small steps that like the number of iterations will be more. The problem with the small step is that number of iteration will be more. But if I take a large step, so suppose there is another valley that is up here. Okay, so if I take last step, then I will jump from here, here, and then will jump from here, here, here. So you can see the point. Okay, that we may miss our point of global minima. So let's suppose here is global minima. We may miss our point if we take very last step. So if I talk about how we can solve this problem. Okay, so what if we take a mixture of both? Okay, what we take a mixture of both small and large steps, small and large steps. So if I make a graph again, so suppose I'm here. Okay, so let's suppose we take a mix. So how we will take a mix? Okay, suppose first I'm taking very large steps. Okay, I'm going here, then here. Okay, so if I zoom in, so at this point. Okay, as the curve is about to flatten, right, you can see at this point I'm here, right, the curve is about to flatten. So what if I change my steps? Okay, if I make it small, so let's suppose here, here, here. So like this is our global minima, right? This is our minima. Okay, so what I'm talking about is that what if we take a mixture of both small and large steps? And so suppose first we are taking large steps, right? While moving down the slope we are taking large steps here. And while the slope is about to flatten, then we are in at this point we are taking small steps. So what I'm trying to say is that if we take a mixture of both, then like we can reach this point, right? Minima point. So this is kind of an like optimal technique, right? Instead of taking very large steps, right? So in what was happening is large step was that we were like, it was the case of missing the point, right? We were missing our global minima. And in case of small step, what was happening is that we were reaching the global minima point, but it was taking a lot of steps, which also means that a lot of time is to be taken. So which is not good, okay? So if I again summarize, right, we are taking a mix of both. So if we take a mix of both, like while going down the slope, we are taking very large steps, okay? But when we are about to reach the flat, then we can take small steps and reach our minima point, okay? So this was about it. And if I talk about another problem, that is global versus local. So like a single point cannot be like used to determine that it is a local, like it is a global minima. So what I'm trying to say is that suppose I have two value here. One is this one, okay? One is this curve, and one is this curve, okay? One is a little bit up here, and one is a little bit down here, okay? So there are two curves I have made, okay? So what is what will happen is that this point this point is global minima, right? And this point is our local minima. And what, like if suppose if a machine thinks that this point is global minima, this point is global minima, then it answer will be wrong. Why? Because we have to reach, we it did not see this point that I'm encircling, right? This is the global minima, this is the least amount of error we can get. But machine on reaching here thinks that this is the error, that this is the minimum error, okay? Machine thinks that this point is the minimum error, that is the local minima. But we have a far down valley which the machine did not see, right? So it is called global minima. So this is another problem, okay? So I think I've covered a lot here, okay? I did not talked about the formula because I think it will be, I think, a bit more complicated to talk about. So like it was just a beginner video, like on what to do, okay? What is gradient descent. So I think that was all about it. Thank you.